Today we are going to discuss about the rate of a chemical reaction. So before going into that, we will discuss what is chemical kinetics. Chemical kinetics is a branch of chemistry which deals with the study of reaction rate and its mechanism. Now the question is, what is meant by the rate of a chemical reaction? If you look around, there are so many chemical reactions that are taking place in our daily life. Some of them take place very rapidly, and some other reactions are very slow process. For example, rusting of iron. Rusting of iron is a very slow process. It takes so many years. And there are some other process which take place in moderate speed. So the branch of chemistry which deals with the rate or speed of a chemical reaction and its mechanism is called chemical kinetics. So first of all, we have to discuss what is meant by rate of a chemical reaction. Now consider a hypothetical reaction. A gives product. It's a hypothetical reaction. Or we can say that the product can be B. Okay, A gives B. It's a hypothetical reaction. Now the rate of this reaction can be written as minus of dA by dt, or that is equal to plus dB by dt. So this is the expression for rate of a chemical reaction. So we consider this hypothetical reaction, A gives B, and the rate can be written like this. Now what is this term? That is minus of dA by dt. So first of all, we have to define rate. It is a change in concentration of reactant A with respect to time. And the negative sign indicate that the concentration of reactant A decreases with the time. Right? Rate of a chemical reaction cannot be negative. Right means it is speed. Speed cannot be negative. So here the minus sign indicate that the concentration of reactant decreases with the time. So if suppose there is a negative sign, we can confirm that it is a reactant. Okay. Now here plus dB by dt. Now what is this one? Square bracket B, that is the concentration of product. So the concentration of product increases with respect to time. So the change in concentration of product with respect to time, that is called the rate of a chemical reaction. So in chemical kinetics, this is a very important topic, rate. It is a change in concentration of reactant or product. Change in concentration of reactant or product with respect to time is called the rate of a chemical reaction. Here we put a negative sign. It indicates that it is a reactant. The concentration of reactant decreases with respect to time. Now we have two different types of rate. The first one is instantaneous rate. Instantaneous rate. And then the next one is average rate. Average rate. Now what is instantaneous rate? Instantaneous rate means it is the rate of a chemical reaction at a particular instant of time. Right? At a particular instant of time. Whereas average rate means it is the from the word itself, average. It is a rate of a chemical reaction in a regular interval of time. That is called average rate. A rate of reaction can be instantaneous rate or it can be average rate. Instantaneous rate means it is a rate of a chemical reaction at a particular instant of time, and average rate means it is a rate of a chemical reaction in a regular time interval. Okay, so this is about the first topic, rate of a chemical reaction. Now we move on to the factors affecting rate of a chemical reaction. Factors affecting rate of a chemical reaction. What are the factors affecting rate of a chemical reaction? The first one is the concentration. Rate of a chemical reaction depends on concentration. So, as concentration is high, then the rate of a chemical reaction will also be high, right? Then the second factor, it is temperature. Temperature. We know that there are different types of reactions. For example, in certain reaction, heat energy is liberated, and then that process is called exothermic process, right? Exothermic process. And in certain other cases, heat energy is absorbed, and that is called endothermic process. Endothermic process. So we have exothermic process and endothermic process. If exothermic means delta H is negative, and for endothermic delta H is positive. So we have exothermic reaction and endothermic process. So suppose the reaction is exothermic. For example, dissolution of sodium chloride, or not sodium chloride, NaOH in water. It's an exothermic process. So instead of cold water, suppose we take a hot water, then the reaction rate or the dissolution of sodium chloride will decreases, because dissolution of sodium chloride is an exothermic process. So the rate of a chemical reaction depends on temperature. In the case of exothermic reaction, the heat energy is liberated, so no heat is required. So if we increase the temperature, what happens? The reaction rate decreases. Whereas in the case of endothermic process, it absorbs energy from the surrounding, so it requires heat. So if we increase the temperature, it furthers the reaction. The rate of the reaction increases. So the rate of a chemical reaction depends on temperature. And the third one, the rate of a chemical reaction depends on catalyst. Catalyst. Now what is a catalyst? Catalyst is a substance which alters or which increases the rate of a chemical reaction without being consumed. The catalyst remains unchanged after the reaction. So any such substance, we can call it as a catalyst. So by introducing a catalyst, we can increase the rate of a chemical reaction. We know that the Haber process, that is nitrogen, right, will combine with the hydrogen, N2 plus 3H2, we get 2NH3, right? All these are gases, and this process will not take place smoothly at the ordinary condition. Suppose we increases the temperature and we increases the pressure, high pressure, then also the reaction rate will be low. But if we introduce a catalyst like iron, then the reaction will take place so rapidly and we get ammonia. And this process is a reversible process, so we have to remove this the product as soon as it's formed, right? So here the role of iron is a catalyst. It provides a surface, right? And on this surface of iron, the nitrogen molecule and this hydrogen molecule get absorbed, and then they will undergo chemical reaction and we get the product. And this is called a heterogeneous catalysis. So the rate of a chemical reaction is affected by the catalyst. Now, how this catalyst increases the rate of a chemical reaction? We know that if we look at the energy profile diagram, right, we have energy, and here we can it can be time. So this is the energy of reactant, this is the energy of reactant, and this is the energy of product. So the energy of product is lower than the reactant, so it's a spontaneous reaction, but it is the reaction rate is low due to the high activation energy, and this energy is called activation. We can call it as activation energy, EA, activation energy. So this reaction is very slow due to the high activation energy. But when we introduce a catalyst, then this catalyst reduces or it provides an alternate pathway. It provides an alternate pathway by lowering the activation energy. So it provides this way. So the activation energy decreases. So the reactant molecule can easily jump this energy barrier and get converted into product. So the role of catalyst. So what is catalyst is doing during this process? It provides an alternate pathway by lowering the activation energy, and thereby a reaction, the rate of the reaction increases. But if we look into that, this is uncatalyzed. This is catalyzed reaction. So the major difference is that in an uncatalyzed reaction, the reactant molecule has to cross over this high energy barrier, whereas in the case of catalyzed reaction, the energy barrier decreases. But the delta H, this is the delta H, the energy of product minus energy of reactant. The delta H will remain the same whether it is catalyzed reaction or uncatalyzed reaction. So, what is mean by rate? Rate of a chemical reaction can be defined as the change in concentration of reactant or product with respect to time, and the rate of a chemical reaction depends on concentration, it depends on temperature, and it depends on catalyst. Okay, thank you.